Welcome to Systems Engineering Hub, where complex systems come to life. From smart tech to space missions, we break down the science behind engineering success. Stay ahead with expert insights, real-world applications, and fun animations. Subscribe now and start engineering the future. Hi, Module 1. Introduction to Systems Engineering. 1.1. What is systems engineering? Definition and importance. Key principles, role in complex projects. What is systems engineering? Systems engineering, SE, is an interdisciplinary approach to design, analyze, and manage complex systems throughout their life cycle. It ensures that all subsystems of a system work together to meet defined objectives and performance standards. Importance: managing complexity. SE addresses the increasing complexity in systems, e.g., in aerospace, transportation, healthcare. Risk reduction. SE identifies and mitigates risks early in the project, reducing costly errors and delays. Optimizing performance. SE helps balance cost, schedule, performance, and reliability. Example: smartphone development. A smartphone is a perfect example of a complex system. It consists of numerous components, such as the CPU, RAM, sensors, camera modules, software, and battery. Each of these components must be designed and integrated to work together efficiently. Systems engineering role. A systems engineer ensures that the design of the smartphone meets customer expectations, performance, cost, battery life, and adheres to safety and regulatory standards, e.g., electromagnetic compatibility. 1.2. The systems engineering process. Phases and models of development. Phases of the systems engineering process: concept, design, development, implementation, production, operations, maintenance, retirement. Concept phase. 1. Define system objectives and initial requirements. 2. Conduct a feasibility study and identify constraints such as cost, time, and technology. 3. Develop an initial high-level concept for the system. Example: for a smartphone, the concept phase includes defining the desired features, e.g., screen size, camera resolution, battery life, and identifying major constraints, e.g., cost, regulatory compliance. Design phase. 1. Detailed system design, architecture, and selection of components. 2. Design subcomponents, e.g., CPU, battery, and interfaces, e.g., how hardware and software will communicate. 3. Create prototypes or simulations to test the concept. Example: in smartphone design, engineers select the screen, battery, and processor based on performance and cost trade-offs. The system architecture is refined to ensure smooth interaction between components. Development phase. 1. Build the subsystems according to design specifications. 2. Begin integration of hardware and software components. 3. Conduct initial testing to identify issues early. Example: hardware components are built, circuit boards, chips, and integrated with the operating system and user interface software to create a prototype phone. Implementation - production phase. 1. Final assembly, validation, and deployment. 2. The system is tested to ensure that it meets all requirements before mass production begins. Example: the smartphone undergoes rigorous testing, e.g., drop tests, performance benchmarks, to ensure it meets all user requirements before being released to the market. Operation and maintenance phase. 1. Monitor system performance and provide ongoing support, e.g., software updates, hardware repairs. 2. Adjust the system as needed to ensure continued functionality. Example: after launch, smartphones may receive software updates to improve performance or address security vulnerabilities. Retirement, decommissioning phase. 1. When the system is no longer viable, it is retired and all data is archived or deleted. Example: when a smartphone is discontinued, Its parts might be recycled or repurposed, and users are encouraged to switch to a newer model. Life cycle models in systems engineering, V model. Each development phase, e.g., design, has a corresponding validation phase, e.g., testing. Example, for a smartphone, the development of the screen design would be directly linked to the screen's testing, e.g., touch sensitivity, durability tests. Waterfall model, a linear, step-by-step approach where each phase must be completed before moving to the next. Example, in the development of a satellite system, the design phase must be completed before manufacturing begins, as each component needs to meet exact specifications before being integrated. Agile model, iterative development with frequent revisions based on feedback. Example, in the development of mobile apps, the system is built in iterative cycles or sprints. Feedback from users helps improve the app's functionality and user interface. Visuals, diagrams of the V model, waterfall, and agile models for comparison. Title, Key Roles in Systems Engineering. Subtitle, Understanding the Key Players. Systems Engineer. Role, systems engineers are responsible for overseeing the entire system development process and ensuring all parts work together effectively. Responsibilities, requirements. Management, establish and maintain the system's requirements, ensuring the system is built to specification. Design coordination, oversee subsystem designs to ensure they meet functional, performance, and interface requirements. Testing and validation, conduct system testing to verify performance, safety, and usability. Documentation and communication, maintain clear documentation and regular communication with stakeholders. Skills needed, analytical thinking, problem solving, strong communication, and the ability to balance competing priorities. Stakeholders in systems engineering. Customer, defines the high-level system requirements and objectives. Example, a smartphone manufacturer, customer, specifies requirements such as battery life, screen size, and operating system compatibility. End users. Users interact with the system and provide feedback on its usability and functionality. Example, smartphone users give feedback on screen responsiveness, battery life, and camera quality. Regulators, authorities, ensure that the system complies with safety, legal, and environmental standards. Example, government regulators may require a smartphone to meet electromagnetic radiation standards to ensure user safety. Project manager, manages resources, timelines, and budgets, ensures that the system is delivered on time and within budget. Example, a project manager for the smartphone development ensures that design, production, and testing phases are completed on time. Visuals, stakeholder map, diagram, showing key stakeholders around the systems engineer and their relationships to the system. Collaborators, software, hardware, and more. Software engineers, develop software components, ikawaii, operating system, apps. Example, software engineers in smartphone development work on the Android/iOS operating system and apps like the camera or messaging. Hardware engineers design and create the physical components, e.g., circuit boards, batteries. Example, hardware engineers select and design the smartphone's processor, memory, and camera. Test engineers develop and execute tests to ensure the system meets specifications. Example, test engineers run drop tests, water resistance tests, and performance benchmarks on the smartphone. Manufacturers and suppliers provide parts or materials for system assembly. Example, suppliers provide the raw materials for the smartphone's components, such as processors, display screens, and batteries. Visuals, collaborators, network, diagram showing how different engineering teams, software, hardware testing, interact to build the final system. Conclusion and key takeaways. Systems engineering is crucial for managing complexity, integrating subsystems into a cohesive whole, ensuring system success through rigorous planning, validation, and continuous improvement. Roles in SE. Systems. Engineers act as integrators, working across disciplines to meet user needs and project goals. That's a wrap on today's topic. If you found this helpful, don't forget to like, share, and subscribe to Systems Engineering for more insights on building smarter systems. Hit the bell icon so you never miss an update. Thanks for watching, and see you in the next one.